Okay, let's wrap up yesterday's lesson. We'll do some examples. Let's see. And we'll also talk about scientific notation. So, right here. Let's go to here. Okay, so I'm going to go over a couple examples, like I said, and then this will be a little bit of review. And so, looking at your properties, you've had about 7 of them. You got about 7 of them yesterday. Well, if we have an exponent out here, we need to use that exponent and multiply by any exponents on the inside. Now, for these numbers that don't have an exponent, I recommend putting a 1. And so you got to take care of those as well. So then this gives us, now here's something that's interesting. We have a -3 that's squared right now. And according to the order of operations, we could work on the inside of the parentheses. Let's see, we got to do please excuse my dear Aunt Sally, right? That's the PEMDAS. So we really got to work inside the parentheses. Probably has a higher priority. And so how does this simplify? Well, inside the parentheses we have to deal with the exponents first. So really this one becomes -9 times 5. And then that's raised to the 3rd power. You see, this negative is not included in the square there. Just the 3 is. There's a difference between -3 squared and -3 squared, like this. You see, this equals -9. This equals +9. Do you see the difference? Because the negative is being squared here, so you'd have -3 times -3. Okay, but in this case, this part here is done first, and then that negative is attached on the outside right here. You see? So make sure you understand the difference between these two. So in this case we'd have an exponent here and an exponent here, and so now we'd have -9 to the 3rd power times 5 to the 3rd power, and this you can do in your calculator. Well, you get 125 for here, and here you get I think it's 729. And then if you multiply these two together, oh, you can't see that very well, can you? You can switch colors. This one's -9 cubed, okay, and then 5 cubed gives us -729, I believe, times 125. Okay, and so if you do that in your calculator, you get a negative as your final answer. I think you end up with like -91,125. Let's see. Yeah. Any questions on that one? Well, now this one, this seems kind of silly because you have 1 to the 4th power. Well, 1 to the 4th power is just 1 because it's 1 times 1 times 1 times 1, right? And so inside the parentheses we would have 1/9, and then we have to the -2 power. Oh well, you done? Okay, so now we multiply the exponents on the inside here, and so we get 1 to the -2 over 9 to the -2. Well, remember, if you have a negative exponent, you can use the elevator trick. You move this one up to the top, move this one down to the bottom, and when you move from the denominator to the numerator, or vice versa, the sign on the exponent changes. So this would be equal to 9 squared over 1 squared. And of course that's just equal to 81 over 1, which simply equals 81. Okay, so those are a couple review problems from yesterday. Now let's talk about scientific notation. It says here, a number is expressed in scientific notation if it is in the form C times 10 to the whatever power, where C is between 1 and 10, and N is an integer. When you work with numbers in scientific notation, the properties of exponents can make calculations easier. Okay, so I'm not sure if it's totally clear up here what they're talking about. What's this talking about right here? Well, here's the deal. I'll do a few examples. Okay, let's say we have these really big numbers, 85 million or something. Now, if you're multiplying these by another big number, it can be really annoying carrying out all these zeros all the time. So mathematicians invented scientific notation. We can write this as 8.5 times 10. Now here's how it works. The original decimal point would be right here if we were to put one in. And you count clear over to here how many decimal places it takes to get there. And then you put that right here to the 10th whatever power. So you would move 1, 2, 3, 4, 5, 6, 7. So you put a 7. Now why does that work? Well, let me just show you a quick example of this. Let's say we have 1.5. Well, and then let's say we have 1.5 times 10 to the 1 power. Well, wouldn't that be equal to 15? And let's say if we take 1.5 and multiply it by 10 squared. Well, that's the same thing as 100, isn't it? So if you multiply that, you get 150. And if you continue this pattern down, 1.5 times 10 cubed, okay? Well, in that case, we get 1,500, okay? Because 10 cubed is equal to 10 times 10 times 10. And so that gives us 1,000, right? So when you multiply by 1,000, you get 1,500. So let's do one or two more of these so you get the idea of how the pattern works. Times 10 to the 4th power. Well, that's equal to, well, multiplying by another 0 here would make it 10,000 here. And so it would make it 15,000. Okay, see, so do you see the connection between this number and the way the decimal is moving? You see, originally the decimal was right here, right? And now it's over here. If we were to write 15, we could write like that. And this is where the decimal would be, and this is where the decimal would be. You know, like if you're writing things in terms of money, for example, you'd write that as $15, right? You'd write this as $150, and you'd have 2 decimal places, right? But look where it was. It was right here, and we moved it over 2. Does that make sense? And now, if you add some decimals here, you'd move it over 3. It's the same number as this. Do you see the connection now? Whatever the number is up here, it causes the decimal to move. And it just moves places. So if you have 1.5 times 10 to the 6th power, what does it do? Well, you write 1, 5, add a bunch of zeros. And what it's going to do is move the decimal from here over 6 decimal places. 1, 2, 3, 4, 5, 6. Moves it to here. And so now you have a really big number here. It's like 1,500,000. Well, so that's what's going on with scientific notation. I hope that's kind of clear. And so, anyhow, to make a number in scientific notation, Basically, the idea is that there can only be one number to the left of that decimal point. So let's say we do the reverse problem. Let's say we start off with 15 trillion. You guys know how to write 15 trillion? That's probably close to what the national debt is right now. It's no laughing matter.
How is it that it got, like, what did it waste to get that much?
Oh, it's crazy. Don't ask me. It's 4% of the GCD now, so it's getting really scary. Okay, but what if we wanted to write this in the correct scientific notation? You see, here's the deal. The decimal would have to be right there. And in order to put it in scientific notation, here's the easy way. You got to move it clear over to here. There can only be one number to the left of the decimal when you have it in scientific notation. Okay? So you would write this as 1.5 times 10 to whatever power. Well, how do you figure out what power it is up here? You just count how many decimal places it would move to get there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You put 10 right here. Does that sort of make sense? How would you write 150 in scientific notation? Well, the decimal place would be normally there, right? So what would we do? We have to move it clear over to here, right? So we'd write this as 1.5 times 10 to something. Well, how do you figure out the power up here, the exponent? You just count how many decimal places you moved it. 1, 2, 3. So it's 10 cubed. So there's some of the basics. Now, how many of you guys have had this already before in like Algebra 1? It should kind of be it.
It's easy though.
It's kind of easy. Okay, well, it can be a little bit tricky, so let me just show you a few more examples before we move on, because it can be tricky. What if we have really small numbers instead? Like, let's say you're looking under the microscope and you're describing the length of an atom. Or maybe something like that, like you're measuring it in terms of meters. So you might have a number that's really, really small now. 0, 0, 0, 0, 0, 0, 0, 0, 1, 5. And it might be in meters. Okay, so that's a really small item, whatever it is. Really small. Now, again, you have to move the decimal so that there's only one decimal place to the left. So we do want to move this decimal clear over to here. That's what we want to do. We want to move it over there. So we do want to write this as 1.5 times 10. But this time, you use a negative exponent. So remember that. Use negative exponents for really small numbers. Use positive exponents for really big numbers. Okay, so how many decimal places will we move it? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'd write this as negative 9. Okay? So, how would you write this one? 0.0000642. How would we write that in scientific notation? It's pretty easy. Just need to count a little bit. We need to move the decimal so that there's only one number to the left of the decimal. So this is the proper placement for it right there. Okay? See, so we have 6.42. Okay? And then we move the decimal over 1, 2, 3, 4, 5. So we say times 10. Now, should this have a minus or positive? It's negative because this is a really small number. You see, it's like 0.000. It's a small number. Use a negative exponent, my friends. So how many? 1, 2, 3, 4, 5, 10 to the minus 5. Okay, so the good news is this. I don't know if you're around. Well, obviously you weren't around, but I wasn't around either when they had the slide rule. Long time ago, they did math using a slide rule, like to calculate a logarithm. They had to use slide rules. Back in space days when they went to the moon, they were calculating things using the slide rule. Now, I was born in 1969, so I have no idea how to calculate using a slide rule. Eventually, they used a calculator. Well, the beautiful thing about it is that you can do these calculations easily on a calculator. You'll notice when you turn your calculator on that you can set the mode and you have some options across the top. Maybe I should switch screens real quick and show you. And so what I'm saying is that you can do this on your own calculator. So I don't know. I'm going to switch screens real quick. So let me do this real quick. I probably won't capture this on Camtasia, but I'm going to go to this screen and show you real quick. So on your calculator, you can see right here. Right now the calculator is set on normal. If you go down and switch that over to scientific notation,
Can you see, Mr.?
can you see it? And put it on scientific. You see it now?
Yeah.
Okay, notice I switched the calculator. Now when I do my calculations, like if I take
There we go, Dan, Mr.
this big number here, can you see it?
Yeah.
If I just hit enter, it's going to write it in scientific notation for me. There, it did it. And it's written right. Can you see it? So let me show you what that means. What they did is they wrote this as 5 times 10 to the 8th. Does that make sense? So all I did was move the decimal over, clear over to here. And they went over 1, 2, 3, 4, 5, 6, 7, 8 decimal places. So now the other beautiful thing is I can put in some small numbers. All right, so let me show you another one. 0.000000. I'll put in. You see how small that number is? I put in a whole bunch of zeros. And now let's put 125. Okay. Now the beautiful thing, once I have it on scientific notation, it will write it in scientific notation for me. So my friends, the thing is, your calculator can do this for you. All you need to do is set the calculator to scientific mode. Now, this can be kind of annoying because if you don't switch it back to normal, it will continue to do everything in scientific mode. And that's kind of annoying because sometimes you want to do like 8 times 9. And you know that's 72, right? Well, they're going to write it in scientific notation. And that's kind of annoying. You go, well, where's the 72 at? Okay, so once you're done doing these calculations, please take your calculator and switch it back to normal. So that way, when you do 7 times 9, you get 63 instead of 6.3 times 10 to the 1. Okay, so I don't know. So if you need help with that, please let me know. I'm going to switch screens now. And I just want to do like maybe one more example involving some letters. So let's take a look. The same rules apply if you have letters. Same rules that we had before. So how are we going to simplify this one? This one, you have the same base here, right? Well, what did that rule say? If you have the same base, you add the exponents. So you can just say, well, that's equal to b, and you can take negative 4 plus 6 plus 7. Which I think is 13 minus 4, which is 9. Does that sort of make sense? Pretty easy. What if there's this one? We have a negative exponent. We have it raised to a negative exponent. So I need to multiply the exponents. Multiply the exponents here. And so I get r to the 6th power over s to the negative 9 power. Now, when you're simplifying things, your book is going to want you to simplify it without negative exponents. So here's the deal. Please make sure you understand the deal. If you're on a test or you're on homework and you have expressions with negative exponents, you're going to lose some points. It's not simplified. Does that make sense? Is that fair to everyone? You all know straight up right now, if there's negative exponents in your answer, you're not done yet. So what that means then is that we need to move this up to the top, because there's a property of exponents that says, look, if you move from the denominator up to the numerator, the exponent changes its sign. So this would be equal to r to the 6th power times s to the 9th power. You see, once it moves up, the exponent changes signs. That's called the elevator trick. And of course, we don't really need divide by 1, do we? And so that's how we would do this one. How about this one? Now we got a mixture of numbers and letters. And for me, I never really found this challenging, but let's go over it. What I recommend is that you deal with the numbers first. So what's 16 divided by 2? I would say 8, right? Now I would deal with each letter separately. M to the 4th power. Is there anything that cancels off here? No. So I would say there's going to be an m to the 4th up here in the numerator. Now what happens with these n's? Well, what's n to the minus 5 divided by n to the minus 5? They cancel, don't they? Or you can do an intermediate step where you move this one to the top and move this one down to the bottom. In that case, you'd have an n to the 5th over n to the 5th. But still, they cancel, right? Yeah? And so, that turns out to be the answer for that one. That's it.
What if it? What if there's one with a 0?
Let's try one more. Wait, what?
What if there's a question like that? That's a 0 outside.
A 0 out here. What's anything to the 0 power?
0.
1.
Oh.
So that problem was easy. Who cares? You have whatever, however complicated expression. Who cares what's in here? That equals 1.
Oh, that's what I was saying.
Yeah. Who cares what's in here? Anything to the 0 power except 0 itself. We're not going to cover that case in Algebra 2. 0 to the 0 power is not equal to 1. I'll just tell you, this case only comes up in calculus, okay? So we'll talk about that case later. But anything else besides 0, we'll just assume it's equal to 1. Okay, well, coming back now to this problem. How do we do this one? You notice there's some numbers in there, there's an A and there's some B's. Alright, so what I recommend, take care of the numbers first. This number does not cancel off with anything, does it? So it kind of sticks around. I'm working inside the parentheses at the moment, and the 2 still stays there. How about these A's though? Can't you see in your head that 2 of these A's, that's like A times A, and this one has like A times A times A, and can't you see that 2 of these are going to cancel off with 2 of these, so that there's 1 A left down here? Can you kind of see that in your head? Okay, that being said, what's going to happen with this B here? It's going to move down to the denominator, right? Because it has a negative exponent. And when it does, it's going to be B to the 1, so you have another B. And I think once it moves down there, then you're going to have a B to the 7th power. And now everything's moved down from the numerator or canceled off. Well, we still have this 3 here. Now let me show you a common mistake people do. Please don't make this mistake. Put an exponent on the 2. People, for whatever reason, they deal with the exponents only with the letters, and they forget to deal with the number. The 2 is inside the parentheses here, so it gets the exponent also. So now what you're going to have is 1 cubed over 2 cubed times a cubed, and then you're going to have b to the 21 power. Because remember what you do, you multiply the exponents when it's raised out here. And so now we simplify this one more step. 1 cubed, of course, is just 1. What's 2 cubed? 8. Well, that's 2 times 2 times 2, right? Which is 8. A cubed, b to the 21 power. Everything's written with positive exponents, so we are done. This section looks easy, but trust me, when it comes to test day, this is a section people just mess up all over the place. So we're going to practice this quite a bit. The remainder of the period, I'd like you to wrap up your study guide, and I'd also like you to work on your book assignment. Whatever you don't finish in class today, you can finish for homework, but the study guide should be turned in. Okay, let's get busy.